Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem, count the number of possible triangles, which is a medium level problem. But trust me guys, we'll solve this problem in such a way that this problem will become very easy. Okay, till then stay with me. So let's see the problem description. Given an integer array ARR, find the number of triangles that can be formed with three different array elements as lengths of three sides of triangle. So this line is pretty self-explanatory, right? That we have been given an array. Now we need to find the number of triangles that we can form with the array elements where three elements will be acting as the three sides of the triangle. So if an array is given to us, okay, now these three elements will be acting as the three sides of the triangle, right? So this is the first statement. But before that, there's a quick catch here. A triangle with three given sides is only possible if the sum of two sides is always greater than the third side. So if we are given a triangle, the sum of two sides should always be greater than the third side, and it should be for all the sides. Okay. So we need to find those number of triangles. Okay. So we have understood the problem description well, right? Now let's see the examples to get more clarity. So in the example 1, the array given is 4637 and the output is 3. So the explanation says there are three triangles possible. One is 346, one is 467 and finally 367. So if we consider the first possibility, the elements are 3, 4, 6, right? Now what is the condition that we need to suffice? The sum of two sides should be greater than the third side. Now, if we add 3 plus 4, if we add 3 plus 4, we are getting 7. And this 7 is greater than 6. So this condition is satisfied. If we take 4 plus 6, we are getting 10. So this 10 is greater than 3. So this is also satisfied. If we add 3 plus 6, then we are getting 9. Now 9 is greater than 4. So this is also satisfied. Now, since this triplet suffice the condition, so this is one of the possible triangle. Okay. In the same way, this 467 and 367 is also one of the possible triangle. But there's a note point here saying 347 is not a possible triangle. Why? Because if we add 3 plus 4, if we add 3 plus 4, we will get 7. But 7 is not greater than 7, right? 7 is greater than or equals to, but it is given that it should be always greater than, not greater than equals to, right? That's why 347. That if we see in array, it is 437, right? So this triplet doesn't suffice the condition and hence is not a possible triangle. Now in the example 2, the array is this and the output is 6 because this all 6 triplets form a valid triangle, right? Similar in this way. Okay. And in the example 3, the array is this and output is 0 because no triangles are possible. So we have understood the examples 2 pretty well, right? Now let's see the constraint. Now in the constraints, the array size is between 3 and 10 to the power of 3. Now seeing this 10 to the power of 3, there's a hint that we can solve this solution within O of n square, right? Within O of n square, we can solve this solution. And if we check the elements of array, it is between 1 to 10 to the power of 5. So we can store the elements inside integer, right? So we have understood the constraints too pretty well, right? So from the example, let's consider example 1 as reference and we'll try to find few observations from it. So this is the example array. Now from this array, we need to form all the possible triangles, which is nothing but all the possible triplets. I may be interchangeably using triplets and triangle, but I mean the same. Okay. Now, what does the brute force approach says? Generate all the possible triplets and check whether the triplet satisfies the condition. Now, what is the condition? The condition is side 1 plus side 2 should be greater than side 3, right? And in the same way, side 1 plus side 3 should be greater than side 2, right? And finally, side 2 plus side 3 should be greater than side 1. So we need to check for this condition for all possible triplets, right? So how do we generate all possible triplets? We can simply use three nested for loops. So we can use three nested for loops and generate triplets and check for this condition. If this condition satisfies, then we can maintain a count variable, and every time if when this condition satisfies, we can increment it by 1. Simple, right? So let's see the brute force code. So this is the code in C++, although the logic remains same. So the function name is count triangles, where array is given as parameter. Now firstly, we have taken array size and stored in n. For now, let's ignore this thing. So here we have created a count variable and initialized to 0, and we are running three for loops: I from 0 to n, j from I plus 1 to n, and k from j plus 1 to n. And from these three loops we'll be getting array of I, array of j, and array of k, right? So I'm sending this three sides to function is possible, whether this triplet is valid or not. If the triplet is valid, then only I'll be incrementing my count to 1. Okay, now what this function does, whatever we have written here, no, the same thing. This function will accept parameters side 1, side 2, side 3, and check for all possible combination. That is side 1 plus side 2 equals to side 3, side 1, side 3, side 2, side 2, side 3 greater than side 1, right? The same thing that we did here, and it will return boolean. Now, since we have used AND operator, these three conditions should be satisfied, right? Now, I have written a weird structure here, right? It is nothing but a lambda function. You can basically write this function outside of the function. But here I have used the lambda function which is present in C++. Okay. So after these three loops gets executed, whatever count we have computed inside this will simply return it. So this is the brute force approach, right? That hits our head whenever we see this problem for the first time. Now let's discuss the time and space complexities. So what will be the time complexity for this approach? What will be the time complexity for this approach? Since it is clear that we are using three nested for loops, so it will be order of n cube. And inside we are calling a function is possible. But this is possible function is just checking for the conditions. It is not looping anything, right? So the overall time complexity will be order of n cube. Okay. And what will be the space complexity? Since we have used only variables, so the space complexity will be O of 1. If we try to submit this problem, right, it will give time limit exceed, because in the constraint itself we have seen, right, that we need to solve this problem in the order of n square or less than that, but this is taking the time complexity of order of n cube, which will definitely give TLE, right? So we need to optimize this problem. Now how can we optimize this time complexity? Now let's see. Before optimizing our code, let's observe few things which will greatly help in optimizing our problem. Okay, so what is the condition that we need to satisfy? We need to satisfy a plus b should be greater than c, right? This is the condition that we need to satisfy. Now let's suppose the c is some big value. Okay, c is some big value, and these both a and b are some small values. Okay, so a and b are small values. Now upon adding both a and b, which are small values, if the summation of these values is greater than c, so this is one of the satisfied condition, right? This is one of the possible cases. And so this is a valid case. So if we try to understand this in terms of example, let's suppose a as 3, b as 4, c as 5. Right. So here we can clearly see that C is greater than 3 and 4. Now if we try to submit these values in the equation, it will be 3 plus 4. 3 plus 4 will be 7. So 7 is greater than 5, right? Where this condition satisfied. So if you're adding two small values and the summation of those small values is greater than the big value, then this is the condition that we needed. So this condition is valid, right? Now what I'll do is I'll interchange the position of C and B. Right. So if I interchange the position, the equation will be A plus C greater than B. Right. Now, whether this equation still holds true for these values, because here there's a combination of small and big value, but here this is just a small value. So if we try to submit these values, A plus C will be 3 plus 5. 3 plus 5 will be 8. So 8 is greater than 4, right? So this condition still satisfies. Okay. So this condition still satisfies. And in the similar way, if we try to interchange the C with A, the equation will be C plus B greater than 8. And now again, if we try to submit the values, C plus B will be 5 plus 4. 5 plus 4 will be 9. So 9 is greater than 3, right? 9 is greater than 3. So this even this condition got satisfied. Now, what does this condition say? Upon addition of two small values, it should be greater than the big value. Okay, it should be greater than the big value. Then only we can form a valid triplet, right? But if this condition fails, we need not be checking this condition, right? Because this is the base equation. To contradict it, let's suppose we have C value as 15. Now, if we try to solve this, 3 plus 4 will be 7, right? And 7 is greater than 15? No, 7 is not greater than 15, right? So this condition didn't get satisfied. So since this condition didn't get satisfied, neither this condition nor this condition will get satisfied. So this is the important observation, right? This is the important observation. Now this condition says one more thing, right? If we try to compare C with individual values, how does the equation look? C will be greater than A and C will be greater than B. Right, now let's suppose A is less than B. Okay, so if we rearrange the whole equation, it will be A is less than B is less than C, right? But here we assume A less than B, but it could be less than or equals to also, right? So let's assume it's less than or equals to. Here it is a equation for individual elements, right? This is equation for the whole. This is the individual equation among the elements, right? So if we try to carefully observe, doesn't it follow pattern? So it is following an order, right? It is following an order. So what we need to do with our array? We need to sort our array, right? We need to sort our array so that we can do this calculation easily. So if I mark down properly, this is one thing that we discuss, and this is the another thing, right? This is the another thing. So firstly, we need to sort the array and we need to check for this condition. Now, how do we check this for this condition? Let's see in the example dry run. So these are the two conditions that we have observed above, right? So according to first condition, we need to sort our array, right? So the array which is given to us, I have sorted it, and this is a sorted version, right? In the second condition, we need to add two small numbers and check whether it is greater than the big number, right? So if this condition satisfy, we need not be checking, right, that A plus C greater than B or B plus C greater than A. This condition itself suffice that we have derived above. So this will be a valid check. But now if we try to map this equation to our array, we need to add two small numbers and get the big number, right? No. So in the array for a given segment, where can we find the big number? At the last position, right? So if we consider this much of segment, where can we find the big number? Here, right? And what can be the possible small elements? It can be both 3, 4 or 7, anything, right? So let's start our execution. We'll start our execution from index number 2. Now why index number 2? Because we need to find a triplet, right? We can't form it by single element or we can't form it by two elements, right? It will be taking at least minimum 3 elements. So that's why I'm starting from index number 2. Okay, here instead of arrow, I'll take k as variable. Okay, so it is as k. Now we'll take the sum of this element and check with the k. So 3 plus 4 is 7. So 7 is greater than 6, right? So 7 is greater than 6. So this condition is satisfied. Now since this condition is satisfied, we'll create a count variable, count, which will be initially 0, and now since this triplet is valid, we'll increment our count by 1. Okay, so we increment our count by 1. Now in this segment there is no other triplet that we can form, right? So I'll bring k pointer one step ahead, so k pointer will be here. Okay, now what two elements we need to take from this segment? We can use two pointer approach here, right? So we can use two pointer approach now. Okay, so let's keep I pointer here and j pointer here. Okay, so according to requirement, we have shifted our problem to two pointer approach, where this k will be moving one step ahead for every execution, right? Now we'll sum 3 and 6. So 3 plus 6 will be 9, right? And 9 is greater than 7, where 7 we have at k position, right? So this condition is satisfied. So we'll increment our count by 1. So we'll increment our count by 1. Now how we will be shifting our I pointer and j pointer? That is a big question, right? So if you check properly, the valid triplet that we form here is 3, 6 and 7, right? 3, 6 and 7. Now, if 3, 6 and 7 is a valid triplet, don't you think 4, 6 and 7 will also be valid triplet? If we check, 4 plus 6 will be 10. So 10 is greater than 7, right? So 4, 6 and 7 is also a valid triplet. So from the ith position, if we are satisfying this condition, don't you think from I plus 1th position will be satisfying this condition? Will be satisfying this condition, right? Because here it is a small value. Here it will be a big value comparatively, right? And if we are moving forward, it will be more big value because the line graph will be going like this, right? Well, the values will be increasing gradually. So instead of adding directly 1, here we directly added 1, right? Initially the count was 1. So the count was 1. Okay. So instead of adding 1, what we can do is we can take the distance of j and I. So what is the distance of j and I? If we subtract j from I, it will be 2 minus 0, which is nothing but 2. So we can directly add 2 here. So 1 plus 2 will be 3. So the count is 3. So in terms of triplets, if we see how it is 2, it is 3, 6, 7, that we have already written here, and one more triplet will be 4, 6 and 7. Okay, 4, 6 and 7, because if it is satisfying for ith pointer, it will definitely satisfy our I plus 1 pointer, I plus 2 pointer, I plus 3, so on till I plus n is less than j. Okay, till I doesn't reach here, it will satisfy for all the possible pairs. So now, as we have computed for all the possible ith pairs above, what we can do? We can safely bring our j pointer to one step behind. Okay, so now again we'll add 3 and 4. So 3 plus 4 will be 7. So we'll check with the kth value. Is 7 greater than 7? No, it is greater than or equals to, but we want strictly greater than. So if at the jth pointer itself, if we are not able to suffice our sum, what we need to do? We need to increase the sum, right? So to increase the sum, what we can do? We can shift our I pointer one step ahead. So we'll shift our I pointer one step ahead. Okay, so I will be here. Since I and j are on the same position, this execution will be stopped, right? And k will be moving one step ahead. So k will be moving from here to here. But since again k is out of bound, so the execution will be stopped, and our output is 3. The count variable is 3. If we check our result, the value is 3, right? So this way we have solved our problem. We have optimized our problem based on these observations, right? It was purely based on observation. Even when we had k pointer here, I have not revealed that we need to solve it to two pointer approach. So when we had k here, at that time I revealed that we need to use two pointer approach. So I have tried to solve this problem in such a way that it would be more intuitive friendly, so that if you find any other question similar to this, you can build your intuition. So the dry run is also done, right? So we'll see the code. So again our code in C++. So firstly we have taken the array size and we have sorted the array. And you know why we have sorted the array. And we have initialized our count variable to 0. So here we are running a for loop for k starting from 2 till n. And we know why we are starting the k from 2, because we need to find the triplet. And internally we have initialized two variables I and j, I being at 0 and j being at k minus 1, right? Because even if we see in the array, when k was here, I was starting from here and j was one step behind from k, right? So that's why j equals to k minus 1. So here the same two pointer approach, where I is less than j, if array of I plus array of j is greater than array of k, what we did? We did count plus equals to j minus I, right? Because if it is satisfying at ith pointer, it will be starting from I plus 1, I plus 2, so on, right? After that only we have decrementing our j pointer, else we are incrementing our I pointer. So after this loop gets executed, whatever count we have computed will return it. So this way we have optimized our problem. But how do we evaluate we have actually optimized our problem? By calculating time and space complexity, right? So let's see the time complexity. Here we have sorted the array of length n, right? So it will take O of n log n. Okay. And here we are running a k loop till n. Okay. So this will be O of n. But internally we are running a while loop while I is less than n j. So in the worst case, it can go till O of n. Okay. If we take the overall time complexity, it will be order of n square. Okay. So the time complexity will be order of n square. And coming to space complexity, instead of variables, we have not taken any extra space, right? So the space complexity will be O of 1. This way, we have optimized our time complexity from O of n cube till O of n square, which is a pretty decent optimization. So this was the video, guys. I hope you guys like this video. If you guys really did, then please like, share and subscribe. It will really motivate me to bring more such content. If you have any query or any doubt, you can post it in comment box. I'll try to respond to it as quickly as possible. If you have any feedback regarding my teaching, you can please comment it down too, so that I can improve on that. So see you guys in tomorrow's video solving any other kind of problem. Till then, stay safe, stay happy and peace.